So last exercise for 4.6. Remember, pretty much all exercises finish with exercises on worded problems. If you want to do well in your SACs, it's really important that you're not only say you're not only just doing the regular questions, you're doing worded problems. The exam next year, exam 2, is practically all worded problems. So you need that experience. We have an open box constructed by cutting out square corners with sides X from a sheet of cardboard, 50 by 30, as shown below, which I'm going to show. You've got the notes in front of you anyway, because I gave them last week. And yeah, they're at the back of 4.5. So we have this sheet here. The dotted lines are the folds. You can see the corners are X and a 30 by 50. Find an expression for the volume of the box in terms of X. What's our equation that we're going to start off with? If we're looking at volume of a box, length times width times height. So this is a sheet of paper, but it's going to be folded up on the ends like that and like that to create an open box, not a closed box, an open box, but it still doesn't matter because we're doing volume here. We can see if I had just a rough sketch over here, my length and my width will turn into the box when we fold the sides up. They're not right. I've done a really bad box. Okay, that's really bad. I think I have to do that again. Where's my eraser? Just give me 1 sec. Sorry, guys. Say that again. So once again, length, width, and height. You can see if this is 50 and this is 30, when we fold things up, we are losing. Yes. Thanks. Thank you. When things get folded up, you lose edges. Okay, if I fold a slide up like that, how many edges am I losing? 2. So we must take away, if I fold our box up, it's no longer 50. It's 50. Take away 2 sets of our corners. You got that, Rita? Well done. Likewise, on the width, it's flat, it's 30. When we fold it up, we cut off X's from each side. So therefore, it's 30, but we've got to take away 2 sides. There's no height here. It's flat. But once we fold things up, how many X's in total is the height? Is it 1x or 2x? Good game. So when we go back to our equation, we've got things to work with now. length is 50 minus 2x. Don't forget to bracket it. Our width is 30 minus 2x. And our height is now x. You don't have to expand it out, but if they ask you to, you can. For example, you can factorize. I can see that I can bring out 2 out of each bracket. 2 times 50, 2 times something is 50 is 25, take away x. Over here, it's a 15 minus x. All right? And then we can once again tidy everything up. You don't have to do that, but the question might say, show that you get to here. So you have to show working out to get to there. Other questions might ask you to expand everything out as well. Okay, so that question's done. B, state the set of x values for which the expression, or B, in terms of x, is valid. When you're dealing with measurement, what values are we not interested in? What sort of values? So when you're doing a money question, can you have negative money?
Oh, yeah.
Sometimes, yeah. Yes or no? No is correct. Yes is correct too, because you can get into debt. Okay, hopefully not. But when it's measurement, can we get negatives? No. If you want negative measurements, then you can join the specialist class. Okay. So in here, we have values in which we've got x, x, and here. What we're trying to say here, our 4x, that part here, it's got to be greater than 0. Can we have equal to 0? Are we interested in equal to 0? If something is 0 in measurement, it doesn't exist. We also don't want 0. And we don't want negative. We're only interested in positive values. That's why we're going greater than 0 here. We're also saying 25 minus x, we want that to be greater than 0. And 15 minus x, we want that to be greater than 0. But we must make sure each coexists as 1. First of all, let's tidy these up. X is greater than 0 over 4. So 0 divided by 4 is 0. Over here, 25 is greater than x. But we can read that the other way. Don't be scared to move the x. Over here too, we can move the x and then rewrite it the other way. So we're interested in where it's 0, where it's 25. Let's do this again. This is 0. Interested in the number 15 and 25. I'm just going to color code this now so everything's a bit more clearer. X is greater than 0. This is x greater than 0. I don't want it. I'm happy with anything above. X is less than 25. I don't want the 25, but I'm happy with anything less than it, even to the negatives for this one. Last one. X is less than 15. We don't want the 15. All the way to the negatives. But we can't have 3 domains going on at the same time. It's just too confusing. We need one domain that rules them all. Okay, like Lord of the Rings. One ring rules them all. We combine all of these into the one thing. We need to look at where do they all line up together. Some have edges on the sides that, notice here, green and blue are going, but red's not happening over here. Over here, blue and red are happening, but green's not happening up here. So how? Where do they all sort of line up? In this section here. And how do I describe that? Jesse, from here to here, what's our overall domain? From which number? From what's the lowest number? 0 to 15. Do I want 0 to 15, Jesse?
No, 0 is greater. No.
Greater than? X greater than 0 and? Awesome.
I mean, 100%.
Yeah, good. I know what you're saying. Here, right in the middle, we are interested in that only. From 0 to 15. Okay? That's the domain you can only work with for this one here. Okay? Okay, we are now going to sketch the graph. Our volume equation, what sort of graph are we going to graph, Tim? Just by looking at it. Try again. Try again. Why is it cubic, Tim? Exactly. X. It's going to be cubic. What type of cubic, Maya? Is it going to be positive cubic or negative cubic? It's going to be positive. That's a positive here. 2 negatives over here make another positive. And 2 positives is like a line. But we're doing cubic, so it's going to be doing that. Positive angle. If we were to sketch it here, remember, we've got 0, 15, and 25. That's my 15, that's my 25, and my 0. This graph here, the key word is without restrictions. We've worked out restrictions, but don't use them yet. Our sketch is going to look like this. Here, here, and here, our x-intercepts. Something like that. Okay. Every worded problem comes back down to what you've been learning at the start. Cubics, quadratics, lines, they're all in there. You just have to find out, dash it out, and make it a bit more simple for yourself. Okay. And I already did working out with our factors, and you know the drill. Before I was doing it with the inequalities. But if they ask you to do full working out, make it equal to 0. Because we're interested when it's 0. Our factors. Lastly, if we were to sketch this with the restrictions, here, 0 to 15, which parts would I erase out? Hudson, am I interested in this bit here? Why? Because it's the negatives. And over here, negatives are here, but we only go to 0. So I'm going to wipe that off. Perry, where else can I make it erase something? If I'm only interested from 0 to 15, which parts of the graph can I start erasing? Everything after the 15 is correct. Thank you. Okay, and today's lolly question, what else do I do? Okay.
You can't include the points on the 0 line.
Exactly. Exactly. In this case here, we don't want zeros. Because once something is a 0 in the equation, the whole thing collapses. And we don't want a box that collapses. We want a box that stays upright. Okay, so that's what's happening there. The last question is simply, you might be asked in a SAC situation, for what values of x is volume 4000? So all you're going to do, would I put the 4000 in the x's or the v? In the v. And then we're going to solve that. Now, the last bit here, just at the end of the video, because I have to go into the CAS